Hi guys, welcome everyone, and thanks for joining us today. I'm Gergely, Business Development Director of Black Cell, and this session is about going beyond traditional SIEM and showing what you can use Black Cell Enterprise Security Monitoring, or ESM for short, and what it really means in practice. So not just as a technology, but also as an operational and business enabler too. Some of you are here from an end user perspective, looking to strengthen your detection and monitoring capabilities. Others might quickly recognize something else, that adding ESM to your portfolio can enhance your own SOC offering and allow you to build services on top of it. This webinar tries to cover both angles. And without further ado, let's get into it. So first and foremost, who is Black Cell and what is our mission? Why are you here? We are a European cybersecurity company with 15 years of experience in protecting complex and digital environments. Today, we operate from 3 locations worldwide and supporting organizations across multiple regions with advanced security expertise. Our mission is quite clear, defending tomorrow and especially critical infrastructure. We deliver end-to-end cybersecurity and covering the entire security lifecycle, from architecture and prevention to detection, response, and to regulatory alignment. Our core departments and expertise include integration, SOC and managed security service, offensive security, cloud, and compliance and governance. We are particularly strong in Industry 4.0, IT, OT, and hybrid infrastructures where traditional security approaches are no longer sufficient. In short, we don't just implement tools, we build resilient, measurable, and continuously evolving security ecosystems. Our leadership team's goal is simple too. We try to provide clear strategic direction, foster collaboration, and drive continuous innovation so our clients can grow securely and sustainably. We believe in Black Cell that cybersecurity should not slow organizations down. It should enable confident growth and operational resilience and long-term success for both parties. That mindset defines how we build solutions, partnerships, and long-term business relationships. And with this 15 years of experience, we decided to create something new, something special. In the last 3 years, we worked hard on our own SIEM solution where all of our past experiences culminated, hence the birth of Black Cell Enterprise Security Monitoring. And with that, I would like to introduce the team behind it and our speakers for today. Firstly, Richard Dörmö. He is the lead architect and director of ESM. Then Ferenc Hegedűs, who is responsible for network security monitoring. Gábor Lázár, the innovator behind Detection as Code solution, and Black Cell's founder and CEO, and the running engine behind all development, Gergő Gyebnár. So I will pass it on to Richard.
Okay, so when we talk about ESM within Black Cell, we actually refer to 2 distinct but closely connected terms. First, ESM represents the competency domain delivered by the ESM team. This includes the full portfolio of products and services you see on this slide, from ESM and NSM capabilities across both IT and OT environments through detection as code, SIEM, NSM, and IOC management, through our core security services such as managed detection and response, detection engineering, threat hunting, and vulnerability management as well. We will go into more detail on these components later in the session, so don't worry about that. Second, ESM also refers to the application itself, a platform we have developed to operationalize these capabilities. This application brings together the service metrics, workflows, and security integrations into a unified operational layer. And by doing so, it enables truly holistic security monitoring across environments, whether we are talking about IT, OT, SIEM, NSM, etc., etc. One of the key advantages of this approach is the unified security view it actually provides. The platform can translate complex technical telemetry into structured, contextualized information that is valuable not only for security engineers and analysts, but also for less technical stakeholders such as management or compliance teams. And this can ensure alignment across the whole organization, which is a massive benefit. In addition, we have developed an integrated AI assistant within the platform. This assistant allows users to upload internal knowledge bases, policies, and certain operational procedures, and effectively embedding organizational know-how into the system. Beyond knowledge management, the AI assistant can also contextualize alerts appearing in the system, helping analysts understand relevance, potential impact, and recommend next steps much better. Under the hood, we use Elastic as our core SIEM engine. We specifically choose Elastic because it is far more than a traditional SIEM. Beyond the traditional log collection and correlation, etc., it can function as a full-featured EDR console, and in fact, its endpoint security capabilities are steadily climbing in independent EDR rankings, reflecting the increasing maturity of the platform. In addition, Elastic provides built-in machine learning and anomaly detection capabilities, and these models are not limited to predefined datasets. They can be applied to virtually any telemetry source ingested into the system, and that includes OT as well. The platform also offers SOAR-like functionalities. This allows us to define logic-based automated response actions, whether that means isolating an endpoint, triggering a workflow, or integrating with certain third-party systems such as email platforms or Teams. And finally, one of the most important aspects is extensibility. The system offers practically unlimited customization capabilities, from data pipelines and detection logic to dashboards and automation flows. The platform can precisely align with the unique operational and regulatory requirements of basically any given environment. And I think that's about it for ESM Core. I will pass the mic to my colleague, Ferenc.
Thank you. Let's look at the 5 pillars that make our network security monitoring both powerful and practical. It starts with being completely passive. Instead of sitting inside your data flow, where it could cause bottlenecks, our system sits alongside it. By using port mirroring or network taps to copy traffic, we are strictly listening. This means zero risk of downtime and zero added latency. Because we aren't intrusive, we are able to bridge the gap between office tech and industrial systems. Our NSM provides a single unified view across the entire landscape, from the standard servers to the controllers on the factory floor. Now, visibility is only as good as your analysis. We don't just look at packets, we look at patterns. This helps to spot suspicious activity even within encrypted traffic or highly segmented environments, areas where traditional security tools often go blind. By capturing this data, we create a single source of truth. This is where the magic happens for the IT-OT convergence. It allows IT and operations to finally speak the same language. We are turning raw security data into operational intelligence. Finally, you can protect what you can see. We automatically identify shadow IT, like rogue or unmanaged devices, the moment they touch the network. Okay, this slide illustrates the architecture of our solution and how it integrates into the existing infrastructure. We don't just sit at the perimeter, we cover every layer of the Purview model. This goes from the business network at level 4 all the way down to field sensors and actuators at level 0. We see the traffic that others would miss. Black Cell ESM is the brain of our system. It collects and correlates the data both from the IT and the OT environment. On the right, you can see a list of over 20 supported protocols. We can speak the language of your machines, whether they use Modbus, MQTT, or specialized industrial protocols like S7com. Deep packet inspection ensures we aren't just seeing that data is moving, but we actually understand the intent of the commands. In short, we take complex data from every level and turn it into clear security alerts. Our goal isn't just to give you more logs, but to provide actionable context. And with that, I would like to hand it over to Gabor to talk about our approach to detection as code.
Thank you, Ferenc. Let's now move on to what I believe is the most interesting part of today's webinar. Detection as code is a modern approach for developing, managing, and maintaining security detections using software engineering principles. It treats detection rules and logic as structured code, enabling security teams to apply version control, automation, testing, and CI/CD practices to threat detection. By adopting detection as code, organizations can optimize workflows, reduce the manual effort required for deploying security use cases, and maintain consistent threat monitoring. Regarding version control and collaboration, we can use Git to track changes, which allows teams to collaborate on detection rules and maintain an audit trail of modifications. Automation and continuous improvement enables automated testing, validation, and deployment of detections, ensuring they are effective before production deployment. This also provides a standardized approach to managing detections across multiple security tools and environments, ensuring scalability and consistency. The SIEM detection as code is a modern and scalable service designed to enhance your security operations with minimal overhead. By leveraging detection as code principles, we deliver a continuously evolving detection rule set directly into your SIEM environment. Getting started is easy. Customers only need to install a lightweight runner on a system. This runner securely pulls and applies the latest rule set to your SIEM environment, ensuring seamless integration and updates. ESM, Elastic, Sentinel, and Splunk are currently supported. We handle the entire detection engineering lifecycle, from research and development to deployment and maintenance. You no longer need to worry about rule creation or tuning. We introduce 2 new high-quality detection rules every month based on the latest threat intelligence, attack techniques, and customer feedback. These rules are tested and optimized for performance and accuracy. The service includes a dynamic MITRE-ATT&CK heat map to visualize detection coverage. We also track alert verdicts such as true positives, false positives to support continuous tuning. All onboarded rules are documented through a fully automated process. Customers also receive a monthly newsletter summarizing newly added and tuned detections. While NSM already delivers powerful capabilities like network traffic analysis, metadata extraction, and anomaly detection, the true strength of the platform is unlocked when paired with our curated signature feed. NSM detection as code is a modern service designed to enhance network security monitoring. It combines automated rule delivery, continuous tuning based on threat intelligence and customer feedback, and detection as code principles to provide scalable, high-fidelity threat detection across enterprise networks. This service enables security teams to deploy and maintain advanced network-based detections with minimal manual effort. Prioritization plays a crucial role in detection engineering by helping us address a key question: what should be detected? The industry standard reference for attacker TTPs is the MITRE-ATT&CK framework. The MITRE adversarial tactics, techniques, and common knowledge framework is a globally recognized knowledge base that documents real-world adversary TTPs used during cyber attacks. Tactics represent the high-level objectives that adversaries aim to achieve during an attack. Techniques describe the general methods adversaries use to achieve their tactics. Procedures describe the specific implementation details of a technique. A MITRE-ATT&CK heat map is a visual representation of an organization's detection coverage and adversary technique exposure across different attack techniques. Heat maps help security teams prioritize detection engineering efforts by highlighting which techniques are commonly used by adversaries targeting the organization, which techniques are likely to be detected by the current detection stack, and where detection gaps exist. To keep up with changing adversary tactics at Black Cell, we create the annual threat intelligence-based retrospective TTP report, which doesn't just inform our strategy, it shapes it. As we move forward, we remain steadfast in our commitment to providing you with detection coverage. It is not only informed by the latest intelligence, but also backed by the power of adaptability. We review the report continuously, and in case of an active service contact, we align for free the detection ecosystem of all our clients. In today's rapidly evolving threat landscape, security teams must continuously adapt their detection capabilities to keep pace with changing adversary behavior. As a result, detection engineering has emerged as a critical discipline in cybersecurity, allowing organizations to build resilient security detection systems. Detection engineering is not just about writing rules. It is a structured approach that involves understanding adversary behavior, understanding system telemetry, integrating detections into automated security operation workflows, and continuously defining detection coverage. The most effective approach to creating and maintaining detections is to adhere to a structured methodical process. The detection lifecycle is one such approach. It ensures that security teams continuously improve their detection capabilities by iterating through a cycle of threat intelligence analysis, rule creation, validation, deployment, monitoring, and tuning. The 6 phases of the detection lifecycle are shown on our slide. Discovery is the first step of the lifecycle, which involves gathering detection requirements. This phase can be initiated from multiple sources. Common sources include SOC requests, red team assessments, and threat intelligence reports, each of which contributes valuable insights into potential threats that require monitoring. The research phase is essential for defining the detection logic that needs to be implemented and identifying the necessary telemetry. If multiple detection requirements exist, this stage also involves prioritizing them to ensure the most critical threats are addressed first. Building upon the insights gained from the research phase, the objective of the development phase is to implement the previously identified detection logic. This translates research findings into detection rules, moving from theoretical understanding to operational capability. The testing process involves the use of 2 key data types: the known good data, which helps prevent false positives by ensuring benign activities do not generate alerts, and known bad data, which confirms that the detection effectively identifies malicious behavior. While both data types have their complexities, a general best practice is to ensure that known good data is sourced from an environment that mirrors the target environment as closely as it can, while known bad data is typically obtained through adversary emulation. This phase may also incorporate unit testing within CI pipelines to verify the specific requirements, such as the presence of required fields and the correctness of their values are met. The second to last phase involves deploying the finalized detection rule into production. This process is most effective when implemented through a detection as code pipeline, leveraging CD automation to ensure seamless and controlled deployment. It is important to ensure detections remain effective, accurate, and relevant over time. Threat actors continuously evolve their TTPs, and if detections are not regularly updated, they risk becoming outdated, leading to false negatives, missed threats. Changes in the monitored environment can over time result in excessive false positives, which also necessitate detection rule tuning to prevent alert fatigue. These tuning efforts constitute the final continuous tuning and improvement phase. Let's continue with the benefits of detection engineering. One of the key advantages is improved threat detection, as it prioritizes behavior-based detection, allowing organizations to better identify real attacks. Also, by leveraging the MITRE-ATT&CK framework, detection engineering ensures comprehensive coverage of real-world attack behaviors, enabling security teams to track and counter adversary tactics efficiently. Another significant benefit is the reduction of false positives and alert fatigue, as high-fidelity detections help minimize unnecessary alerts, improving operational efficiency, and allowing analysts to focus on real threats rather than being overwhelmed by excessive noise. Additionally, detection engineering empowers threat hunting by providing high-value hunting use cases, enabling security teams to conduct proactive threat identification and uncover hidden threats. It also enhances log visibility by ensuring that organizations collect and analyze the right logs, filtering out unnecessary noise and allowing security tools to function efficiently with relevant and actionable data. Furthermore, by focusing on detecting TTPs instead of IOCs, organizations force attackers to work significantly harder to evade detection. This approach increases the operational costs for adversaries. That's all for detection engineering. Let's move on to our threat intelligence services. Our DGA detection solution runs on a locally deployed neural network trained on real-world malware datasets. The engine identifies algorithmically generated domains commonly used for command and control communication. Because it operates entirely on premises and does not rely on any external APIs, detection is fast, private, and suitable for environments with strict data locality requirements. The next item in our portfolio is our high-level indicators of compromise solution. We maintain an up-to-date repository of known command and control IP addresses, malicious domains, URLs, and file hashes. These indicators can be ingested into the SIEM platform to generate alerts whether any of them are detected within the environment. The third capability is DNS fuzzing for cyberspotting detection. This engine is designed to catch supply chain style attacks. Customers define a list of protected partner or brand domains, and the system generates and monitors malicious permutations. These are selectively checked against message trace and proxy logs, and when a cyber-squatted domain is detected in the traffic, an alert is raised for investigation. Finally, attack surface monitoring is a comprehensive monitoring stack designed to track the organization's external digital footprint, which often serves as an initial attack vector. It assesses emerging vulnerabilities, exposed services, open ports, subdomains, and potential data lakes within the defined scope. That's everything from my side. Gergely will now walk you through our additional services.
After my colleagues, I would like to introduce the service and the business opportunities that built on the top of our product portfolio. Regarding managed detection and response, we provide 24/7 services, L2 and L3 on-call services. We work with SLA KPI penalties, and on this slide, you can see the standard SLA agreements. However, I must mention that we can also serve real-time DoD or now DOW level SLAs, depending on the client's needs. Mean time to respond and mean time to detect are metrics that cannot be fully objective and depend on many external factors. Therefore, we offer mean time to acknowledge based on SLAs as a reliable alternatives. The integration can vary depending on the client and specific needs. Threat hunting services are usually requested by more mature clients, but not exclusively. Therefore, we differentiate three domains of threat hunting. What Gábor mentioned, the query-based threat hunting is a very powerful and very useful because detection engineering process may exclude conditions from reactive use cases in a case of false positive management. These must be handled proactively and iteratively by the threat hunting team, and validated findings must be integrated into the reactive use cases with the proper context. Retrospective analysis is an IOC and signature-based historical investigation where we locally collect, for example, source and destination IPs, executables, and other internal sets, and periodically, typically quarterly, we run these against our malicious IOC and signature databases. If we identify a communication with a non-malicious source, then we generate a hypothesis that we validate or dismiss. And of course, we have the machine learning based on anomaly detection, which rarely can be interpreted reactively, but is extremely valuable in proactive threat identification. Next, please. There are many excellent or less excellent technologies on the market. One of our strengths is that we can cover all these functionalities, but I want to highlight something else. There are over 60 security vendors just in the endpoint security market. Only around 4 of them can provide file integrity monitoring, and another 4 can provide memory corruption detection. So the question is, which EDR tool is actually the best for you or our customers? With ESM and our company behind it, we can manage all these detection engineering and tooling challenges based on the client's sectors and geo-specific needs, considering the relevant tactics, techniques, and procedures, and the data sources. This immediately highlight the detection gaps. And the other important thing is the log source coverage, which is beneficial for us and highly appreciated by the clients. So business is business. Since our profession is usually not a moneymaker for most companies, we must continuously adopt and offer the best as we can, both financially and technologically. With our partner program, we can confidently say the client acquisition and the client satisfaction can become a perfect match in heaven. In the last 15 years, we have not lost a single SOC client in technical or financial reason, and we are committed to maintaining this track record. To extend this vision to our partners, we have built everything that might be needed: service design, the action cards, against the legacy or the magical UX technologies, the pre-sales support training, and references across all sectors in the globe. By the book, we differentiate two types of partnerships. Business partners can be low-hanging fruit for companies just starting in cybersecurity, or those with network or advisory experience, or those simply want to leverage process opportunities based on existing client relationships. Solution partners require deeper involvement because local engineering capabilities are required and needed. But we do not want to overwhelm partners with forecasting or unnecessary administration, so we simplified the workflow and removed the annoying bureaucracy. Talk is cheap. Let's move forward to the demo. Richie, please go ahead.
Thank you. Okay, so after all is built up, let's finally dive into the ESM system. Hopefully, no demo curses will occur. On the first page, you can see what we call as the main dashboard, where a lot of the relevant information is visible at first glance. We have the current open alert statistics, nothing unusual there. However, on the next one, we have squatted domains, where we can see the type of domains that are potentially being squatted on. Of course, these are domains which are relevant to us. Next one is the attack surface monitoring, or ESM. Here we monitor the external attack surface of a customer based on exposed IPs, domains, subdomains, and its corresponding ports. On the next one, we can see the latest alerts, but we will cover it in more detail in a couple of minutes, so I wouldn't waste too much time there. Next one is logging gaps, which is basically telling us what hosts are onboarded into the ESM system. Of course, we need an asset list for comparison, and the results is basically telling us that the newly updated host isn't onboarded into the security coverage, so we should address that. The next one is the top TTP statistics of the current alerts, where we can get an overview of the TTP trends occurring within the infrastructure. The data for the two widgets on the bottom are coming from the network security module, or the NSM. The first one is just basically a network analysis of the IT and OT environments. The second one is a trend analysis based on IPs, ports, and user agents. We specifically choose user agents as our third metric because during our many threat hunting procedures, usually the user agents results were the most interesting by far. So we like to think about it as an active threat hunting dashboard. So that's about it for the first page. And on the second page, basically it's all about alerts and investigation of these alerts. On the top of the screen, you can see a few statistical information, but wouldn't waste too much time there because since we are here, let's investigate an actual alert. So let's look at this one. Since it's critical, we should prioritize that. This alert came from the NSM model. We can see it based on the rule name, and it's specifically mentioning a protocol named Goose, which is commonly used within OT substation environments. You can see a few information like alert description, reason, investigation guide, where the analysts can find hints and useful information in regards to the alert. Lastly, we have highlighted fields which contains the most relevant information within the alert, where we can already see a few telling signs like the timestamp mismatching and the sequence numbers are not normal. So we can assume that it's probably not a regular event. You can also pivot to the drill down dashboard for more information by clicking on the investigate button. But as we mentioned previously, we have an AI assistant, so why don't we use it to gather context about the alert, right? So within the response, the assistant basically confirmed our suspicion that it wasn't a normal event. After that, usually comes the triage and incident response workflow, where we can contact the affected client and escalate the alert. Let's quickly look at another alert where we have an EDR installed, a security event log cleared, which is again not a normal event and could be a really good indicator of compromise. So we can isolate the host here, but I will show another way in a few seconds. So I think that's about it for the alert section. The third page is dedicated to detection as code, where the client can view the onboarded detections our labs team produced. It's not really a complex page, just the collection of our detection capabilities, and that's basically it. Lastly, we have the health grid, which provides us with the full visibility of our components and can manage the onboarded agents from here, both from an EDR and an operational standpoint. And as I've said before, here we have the ability to isolate the host, which showed up in the previous alert. This basically means that the ESM system is the only system which can communicate with the host from now on, and it's completely cut off from the rest of the network. And I think that basically covers our core capabilities. We could honestly talk about this product for hours, and we naturally have a lot of plans and developments on the roadmap, but that's for later. Thank you for listening.
Thanks for the demo, Richard. So thank you for all your attention and especially for engaging with the demo and the technical and business insights today for my colleagues. If what you have seen was interesting or sparked any ideas, whether from in the user perspective or from a partnership perspective, let's keep in touch and continue the conversation that we just started. We are happy to explore next steps together. I will insert to the chat now forms, which if you have the time, we would appreciate if you would fill out and rate what you have seen today and how relevant it was for you. And we can track down next steps. And of course, I would like to leave some time now and engaging with you in this chat bracket as well. If you have any questions, it will be a best effort based on best effort. It will be a free grab with my esteemed colleagues here. So if you have any questions, shoot now. Hi, Luis. It's okay. Recording has been captured and it will be sent out for you shortly after the event. Be glad you joined. Well, if there is no questions left, okay. So you were able to hear us, Luis. That's and I assume the other participants too, which is a great sign. Okay. So questions once, twice, and last round. Then have a great day. Oh. So our capabilities.
So our capabilities, sorry to grab the word, but it will be another webinar, but we can say that we arrange everything natively. So we are leveraging the local Python environment and we are highly dependent on the local RAG-based LLM architecture. Also with the bad classification and also the queries are used by the LLM. So not just MCP agents, but also the querying is a local instance which is running the automation. So the human in loop methodology can be remain on P1 and P2 severity tickets in the future. Hope it's answer for your question in short way.
You're welcome.
No, no, we need the. So we are not a packet broker, a vendor. We are not selling tabs. So we need the mirror traffic. Also, it's a mirror traffic strategy is also a question. So you can have the north and the south traffic from the switch or the core firewall, but it's very interesting if you have a virtualization cluster to get the internal east and west traffic also. So we need this traffic for our appliances or VMs or whatever we want, but we are not having any kind of technology for that. Or just one short note, we have a sensor node. And we will forget to mention, for example, in the electric sector, in the substation, we are not get the data from all the substation, but we put there a small machine and it do the sensor way if you ask that.
It's a physical sensor.
Yeah, it's a physical sensor. Yeah. It's a rugged one with industrial environments. Is it an answer, Alvar? For your question, or you are curious about absolutely other thing?
Yes. Okay. Be brave. We don't bite. So, any roadmap plans?
Yes, absolutely. So you can see that we are uploaded the inventory from the CSV file. If in the future, in the roadmap, we would like to automate this inventory, and not just for the OT, but for the IT as well, because this logging gap analysis is really, really important. Because if there is a new onboarded domain controller on the app environment, or somebody is just a Raspberry Pi on the OT network, we need to get immediate information, and not just the alert aspect, but in the logging gap analysis aspect as well. This is our first response, and we are continuously tweaking our regression algorithms. We are using XGBoost, but we are also moving for other engines as well. Yeah, Zscaler and NSS Cloud is absolutely fine for us. Oh, Brent and Dazar, it was a compact answer for both of you. Okay, Nanolog, I don't know. We will answer you by email.
Okay. Any questions remain? Okay, guys. So the recording will be sent out to you shortly, and it will be also published. And with that, I would like to thank you for your time. Have a great day, and hope we stay in touch soon.
Much appreciated your time. Cheers. Bye.
Bye-bye.